Hello, and welcome to this lesson on carboxylic acids as weak acids. In today's lesson, we will firstly understand the acidic nature of carboxylic acids and their behavior in water. We will then learn why carboxylic acids are classified as weak acids. Finally, we will explore the typical reactions of carboxylic acids, including their reaction with carbonates. So far, you have learned about the homologous series and functional group of carboxylic acids. You are familiar with their general formula, RCOOH, and how they fit into the broader category of organic molecules. Building on this foundation, today's lesson will enhance our understanding of chemical behavior and acidity by examining how carboxylic acids ionize in water. Let's get started. One of the most important characteristics of carboxylic acids is their acidity. The COOH group can donate a hydrogen ion, H+, making these compounds acidic. Let us take the example of ethanoic acid. When ethanoic acid dissolves in water, it dissociates to form an ethanoic ion and a hydrogen ion. However, carboxylic acids do not fully dissociate in water. Instead, only a small fraction of the acid molecules release their protons. This incomplete ionization is why carboxylic acids are classified as weak acids. You can look back on the chemical changes unit if you need a refresher on weak and strong acids. As carboxylic acids are weak acids, they typically have a pH ranging from about 3 to 6. The exact pH depends on the specific carboxylic acid and its concentration in solution. For example, a dilute solution of ethanoic acid usually has a pH around 4 to 5. Compare that to a strong acid, like sulfuric acid, which has a pH of around 1. Since carboxylic acids are weak acids, they can still participate in typical acid reactions. Perhaps one of the most notable of these reactions are those with carbonates. When a carboxylic acid reacts with a carbonate, the reaction produces three main products: a salt, carbon dioxide gas, and water. The general equation is carboxylic acid plus carbonate produces salt plus carbon dioxide plus water. Let us reuse ethanoic acid as an example of this. When ethanoic acid reacts with sodium carbonate, it forms sodium ethanoate, carbon dioxide, and water. However, because carboxylic acids are weak and do not fully dissociate in water, their reactions with carbonates tend to be slower compared to those involving strong acids like hydrochloric or sulfuric acid. In practice, you would observe this reaction happening more gradually, with a slower release of carbon dioxide bubbles due to the weaker acidic nature of carboxylic acids. This is a key difference from reactions involving strong acids, where the production of carbon dioxide is much more vigorous and rapid. Understanding these fundamental properties and reactions of carboxylic acids allows us to grasp their significance in both chemical processes and everyday life. In today's lesson, we explored the acidic nature of carboxylic acids. We learned that when a carboxylic acid dissolves in water, the COOH can release a proton. We highlighted that the dissociation is only partial, making these compounds weak acids with a typical pH of 3 to 6. We then examined the reaction of carboxylic acids with carbonates, producing a salt, carbon dioxide, and water, highlighting the slower reaction rate compared to strong acids. This understanding forms the basis for studying the broader chemical behavior of carboxylic acids in various applications. Watch the rest of the GCSE chemistry course at Sophos Education.